Okay, excuse me. Here are the theoretical problems. The first one's a little intense, but the second one is pretty straightforward. So, kind of something to think about before we start on problem one. If I have a probability density function and I integrate across its limits, it's going to go to 1. That's just by definition, and we're going to use that. So, what we're going to do is take this. So we have our ax squared e to the minus bx squared dx is equal to 1. That's if I integrate across that function. A is a constant, so I can pull it out on the outside. So what I'm going to do is work on the integral on the inside, get an answer for that, and then substitute back in a times this material is equal to 1 and solve for a. Okay, so let's go to work on our integral. I'm going to let y is equal to x squared. Then x is equal to y to the 1/2. I just took the square root of both sides. But I'm also going to need an expression for dx, because I'm going to change dx to dy. So if I take dx, then I'll take the derivative on the right-hand side with respect to y. So I'm going to have 1/2 y to the minus 1/2. That's just pulling that 1/2 down and subtracting 1 times dy. So now I'm ready to put this stuff back in our formula. So I have y e to the minus by, then times my expression here, 1/2 y to the minus 1/2 dy. Now I'm going to combine them. So I had y here times y to the minus 1/2. That gives me y to the positive 1/2 times 1/2 times e to the by dy. Then I'm going to pull the 1/2 out. So here I have my integral going from 0 to infinity of y to the 1/2 times e to the minus by dy. Okay? All right. But that makes me think of a gamma probability distribution, which looks like this. So I have lambda to the r over the gamma function, we'll talk about that in a second, times x to the r minus 1 times e to the minus lambda x. Okay, so I've got the second pieces. I've got y to a power times e to a minus constant variable power. Okay, so I just need my constants out in the front. So what I can do, I'll take my expression, I'll put in the constants on the inside that's going to make that go to a gamma. So I know that I have y to the 1/2 power. So that 1/2 is equal to r minus 1. So I have r minus 1 is equal to 1/2, or r is equal to 3/2. Now, again, going with turning this into a gamma, I want to have my lambda is just the power that I'm raising the e to, the constant power. So in this case, it's just b. So I'm going to have lambda to the r, that's b to the 3/2 power, all over the gamma function of r. So that's going to be the gamma of 3/2. And we'll talk about how to solve that in a second. So if I multiply inside of the integral by this part, then I need to take the reciprocal of that and multiply on the outside of the integral. So I just flip that over. I still have the 1/2 sitting out there. Now I have the gamma function of 3/2 over b of 3/2. Okay? But to determine the integral, remember this is a gamma probability distribution. If I integrate across that, that's just equal to 1. So my left-hand side is equal to 1/2 times gamma of 3/2 over b to the 3 halves. Okay, so that was my integral. Now I'm going to go back here. I have a times all that stuff is equal to 1. And I'm going to solve for a. So I multiply by the reciprocal of all these, and I have 2 b to the 3 halves over gamma of 3 halves. But I looked that one up, and gamma of 3 halves is square root of pi over 2. So if I plug that in, we'll end up with 4 b to the 3 halves over the square root of pi. And that's it. Kind of complex, but you have to go through it step by step. Okay, 7 is very easy. If I have the variance of ax plus b, that's just going to be the variance of a squared times the variance of x. But we were given, and there's b is a constant, so it has no variance. So this means that we have the variance of ax plus b is equal to a squared times sigma squared. Then to get the standard deviation of that, you just square root both terms. So you have the square root of a squared sigma squared. And this becomes the absolute value of a times sigma, because sigma is always positive.